Here's the latest audio research news from the transmitter. Neuro's Arc, Spying on the Secret Sensory World of Ticks, by Callie Murray. Ticks love Carola Sta. Practically every time she goes on a hike or even just plays a sport outside, she soon finds a tick latched onto her. I always thought, okay, ticks are really looking for me, says Sta, a group leader in the Institute for Neuro and Sensory Physiology at the University Medical Center Göttingen. She often wondered what made her so appealing to these arachnids. That interest turned scientific when she attended a talk by neuroscientist Leslie Vossel about how mosquitoes seek out blood feasts. Stadell pored through the tick literature and discovered that almost nothing was known about how ticks find their targets, despite the deadly effects they can have on people and animals. A tick's main sensory tool is the Haller's organ, located on the forelegs. The exact sense it powers has proved difficult to pin down. There is strong evidence it is involved in olfaction, but studies have also cast it as a taste, hearing, and thermoreception organ. Some researchers have even claimed ticks can detect microwaves, although those data are less convincing, Stadell says. There is a lot of mythology when it comes to ticks, she adds. Stadell spoke with the transmitter about her lab's efforts to study the sensory neurobiology of the tick, what makes someone a tick magnet, and why there should be more tick neuroscientists. This interview has been edited for length and clarity. The transmitter. How do ticks find their next meal? Carola Sta. When you look on the internet, the first thing you find that ticks are attracted to is carbon dioxide. Originally, my lab wanted to look at multisensory processing. But we cannot study multisensory processing if we don't know what carbon dioxide is doing as a single cue. The problem was that I had no idea what responses to look for when I applied carbon dioxide to ticks in the lab. Did the ticks start to climb? What are they doing? The literature didn't give any examples. I saw that ticks did not start to walk when they were exposed to carbon dioxide. They didn't start to climb. The only thing they did was sit there and wave their forelegs. So carbon dioxide seems to be a very important activator, but it's not an attractant. It activates ticks to look for other cues. The transmitter. What are some of those other cues? Carola Sta. This likely depends on the life stage. In the past, people saw ticks as very static, like, oh, a tick smells something, and then it finds it attractive or not. But we know it's not so easy. I mean, just imagine a coffee in the morning might be really attractive, but at 9 in the evening it might not be that attractive. For feeding on animals, the most important cue is definitely olfaction. Carbon dioxide is an activator, and other host-specific odors. Ticks are super mechanosensory animals. The whole tick body is full of mechanosensory hairs. When they get exposed to carbon dioxide, they wave their forelegs, which makes more turbulence in the air. So odors reach their olfactory organ better. But the other thing is, they really want to cling onto something. They get this touch compulsion. They also have taste receptors and can do thermoreception. These are the 4 senses that you can say for sure, okay, they have receptors for this. But I think when you look on the internet, every single sensation you can think of was at one point attributed to the ticks without scientific proof. The transmitter. What projects are you currently working on? Carola Sta. We are generating resources. We want to do functional studies and figure out what different neurons are doing, where olfaction is processed, and so on. But first you need a map of the tick brain. We are mapping the tick brain, which is called the synganglion. The forelegs are most likely the only olfactory organ. We identified the olfactory lobes, where olfactory information is processed. And so far, the only axons we see going there come from the Haller's organ on the forelegs. We are doing a lot of anatomical studies right now, such as trying to look inside of the ticks with micro-CT imaging to figure out what is inside of the mouth parts, what is inside of the Haller's organ, how many neurons are there. There are lots of things attributed to this organ that it most likely doesn't do. Just from the anatomy studies, I think we will be able to get rid of some of the myths. The transmitter. What does the field of tick science look like? Are there other neuroscientists? Carola Sta. It's very diverse, I would say. A lot of ecologists and pathologists are studying ticks. It's very different from the neuroscience field I was exposed to before. For example, when I go to conferences now, I would say 80 to 90% of the people are veterinarians. I think I'm the only person in the field with a real neuroethology background. More and more people are starting to also look at behavior and also the neuroscience perspective, but they are normally not really trained in neuroscience. The transmitter. What makes ticks an interesting research subject for neuroscience? Carola Sta. There are a lot of low-hanging fruits with ticks. There are so many open questions that just are waiting to be addressed, and way too few people are studying these animals. They are major vectors for diseases, and everything we have against ticks right now targets the nervous system, yet we really don't understand the tick nervous system. Then, from a biology perspective, ticks belong to the class Arachnida, but they are not spiders. There are millions of years of coevolution between spiders and ticks. And of course, they're also not insects. They are very far away from insects. Ticks are ticks, and they are perfectly suited for a parasitic lifestyle. There's a lot to learn about how evolution made this purely parasitic animal. The transmitter. Do you have a hypothesis about why ticks are so attracted to you? Carola Sta. That's the million-dollar question in the tick field. Are some people tick magnets? And if so, why? Of course, I do have hypotheses. I don't think it's my blood type or that I'm exhaling more carbon dioxide. I think it has something to do with the sugar content in my blood. I'm a sugar addict. This is something we would love to study at one point. What is it that ticks like when they get blood? For mosquitoes, ATP and some sort of sugar is really important for them. But for ticks, what makes blood attractive to them is completely unknown. This audio was created using artificial intelligence. Stay up to date with the latest neuroscience news and perspectives at thetransmitter.org. Follow audio research news on Spotify, YouTube, or wherever you get your podcasts.